Welcome back. So we have studied about the outliers and we also looked briefly on the difference between the outliers, anomaly and the noise points. Now in this video we'll look into the methods of detection of outliers and how we can remove them. Okay. So here you can see whenever we talk about outliers we have two kind of analysis. One is univariate analysis and another is multivariate analysis. On univariate analysis, we have primarily three methods. We have visualization methods, we have IQR methods, and we have hypothesis testings. This hypothesis testing we will cover next week, perhaps. In visualization method, we have boxplot and scatterplot. So let's suppose that we have a data on univariate, so it means that the data is only having a single column. Okay, so let's say this is the attribute on which we want to make our univariate analysis to detect the outliers. So what we will be doing, we will be just taking the data and we'll be plotting a scatter plot of that particular data. So let's say the data is something like 2, 4, and let's say 100, let's say 50, let's say 60, let's say -8. So the plot will be something like, so clearly from the scatter plot you will be getting some basic idea on what are the extreme points. So if I look on the graph itself, I'll find that this is the extreme point. I can also regard that this is also my extreme point. So it depends on the perspective or the context of the problem on which we are trying to find out the outliers. So let's say that if I am finding my whole observation setup is defined in such a way that I am dealing with the population of working class people, then my outlier can be a person who is having an age of 100 something, let's say 105. Okay, so it depends. So on visualization you can get some idea by looking at the graph. Okay, so first thing that you can do is scatter plot. Now the second thing that you can do is box plot. So we'll talk about the box plot also. Let's just briefly see first that what are the other methods that we are having. So we are having the second method, that is IQR, and it is known as interquartile range method. This box plot and interquartile range method are very much related to each other, and we'll see it how these two methods are related with each other in later part of the video. Then we are having hypothesis testing. So there are a lot of hypothesis testing methods that are available to perform the univariate analysis to remove the outliers, and one very famous test is Grubbs test, and it is actually the most popular hypothesis testing method that is available to us in this whole univariate analysis of removing outlier. The second one is Dixon test. Both of these hypothesis testing methods are quite similar, but there are some fundamental differences that Dixon test is following. The third one is general extreme studentized deviate testing method. So it is just a generalization of Grubbs test, and we will see all these tests later in our lectures. Okay, now when we talk about multivariate analysis of removing outliers, there is one famous algorithm that we are having, dbScan. Okay, and the full form of dbScan is density based spatial clustering of application with noise. Okay, so it clusters the point on the basis of the spatial density. So first we project those points on some space and we find out what are the denser regions on that particular space, and we draw our cluster with those denser points, and the points that are not covered on that clusters, they are termed as outliers. Okay, and we'll look into the great details of dbScan also and how this algorithm works actually in later on the video series. Then the similar algorithm is also there, that is k-means clustering. So there are a lot of questions, even in interview also, if you'll go, people can ask that what is difference between k-means clustering and dbscan. So we'll study k-means clustering later part of this whole lecture series, but the fundamental difference that I would like to tell you is that for k-means clustering you should always be knowing how many clusters are to be formed from the given data. But in dbscan you need not to specify how many clusters your algorithm should be making. You can only provide certain parameters like epsilon, that is the radius, and the n, that is the number of minimum point required to make a point as core point, and that's it. You'll be getting a lot of clusters. In k-means clustering, I feel you have a problem of knowing the clusters before clustering the data. So if you have some general idea on how many clusters the whole data should be having, then you should be using k-means clustering. If you don't have any idea on the classes or the clusters that a data can have, then you can use the dbscan method. Okay, so this is the fundamental difference. Now one more thing is there. Whenever we are having the multivariate data, you can always convert that multivariate data to univariate data by compromising on some amount of information. So, and that compromise is made by transferring all the attributes to some different vector space with the principal components as their axis or as their attributes. Now that can be done by using PCA, that is principal component analysis, and we'll learn about PCA also in later part of the lecture series, so don't worry about that. Now let's see what are the details that connect the boxplot and the IQR method. So let me change the slide. You can see that on the univariate analysis of removing outliers, we have the first method as visualization. And in the visualization also we looked at the scatter plot, and a scatter plot is nothing but just a plot between the index of the point and the value of the point, and by looking at that particular graph we can see what are the extreme points that are there, that are away from the dense region of the graph, and we say that these extreme points are nothing but outliers. Remember that IQR always assumes that your data is distributed normally. So on the box plot you see this top portion of the box, it is the Q3, okay, and it is known as the 75th percentile of the data. The mid line here will be your Q2, and it is the 50th percentile of the data, also known as median. The bottom line is known as the 25th percentile of the data and represented as Q1. Now these are the quartiles that we form on the data itself, and then after finding these quartile, we use these quartile to find out this high range and the low range. And basically high range is nothing but Q3 plus 1.5 times IQR, and this IQR is the difference between, so IQR will be the difference between Q3 and Q1, and similarly low will be Q1 minus 1.5 times IQR. Okay, so this is the box plot, and how this is related to the IQR method. So in IQR method we calculate this IQR, then we find out high and low, and we say that whatever the points that are not coming in this particular range, that is from low to high, these points are termed as outliers. So if the point is not coming in this range in between high to low, it is coming either below low or above high, it will always be termed as outlier, and that is what happens in IQR method. So this is it. We have seen briefly what is box plot, how it is related to IQR method, and all the other information that was basically covered during lectures. So I hope that you are revising the things consistently, and all the best for your assignments. Bye.